Okay guys, you're probably wondering why the heck I showed that video. The reason I showed that video was, I don't know about you, but sometimes when I feel like I'm studying, I feel like no matter how hard I try, I never seem to get the right answer. So that's the way I feel sometimes, but we're going to try and change that today by going through some stuff with our Chapter 3 practice test. Okay? Use Pythagorean theorem to find the missing variable. Should be just find the missing variable. Write yes or no if the three sides qualify for Pythagorean triple. Okay, ladies and gentlemen, you need to identify what the longest side is. Okay, so in this case, it's across from your right angle. It's just like when we do the SOHCAHTOA. All right, you got it. So here's my A and B. Again, doesn't matter which way we put them. X squared plus 12 squared equals 13 squared. Okay. X squared plus 144 equals 169. If I subtract 144 over, I get x squared equals 25. Square root both sides, I get x equals 5. Alright, let's take a look at our three sides. 5, 12, 13. Okay, are they all three real numbers? Yes, so therefore yes, Pythagorean triple, PT. Okay? Alright, over here, this case x is my c. Alright, these are my interchangeable a and b. I can do x squared plus 24 squared equals, sorry, did I say x squared? 8 squared plus 24 squared equals x squared. And then, so we are going to do 24 squared, 576, 64 plus 576 equals x squared. 576 plus 64 is 640. Now on the test, we're going to ask that you simplify down these square roots. So you're thinking about a perfect square that goes into 640. Okay, it actually kind of pops out at you. 64 times 10. And then what's the square of 64? 8 root 10. Okay, now you see how this one has a square root in it? Therefore, this is not a Pythagorean triple. Okay, so we can just put no PT. Alright? Okay. Number 2, decide whether the following sides form a right acute or obtuse triangle. Work must be shown to receive credit. Okay, just a quick little beginning part. I know you guys all know that a squared plus b squared equals c squared. It's a right. But if a squared plus b squared is larger than c squared, that's acute. Okay? If a squared plus b squared is less than c squared, that's obtuse. So, let's take a look. Root 8 is a little less than root 9, which is 3, so this is definitely smaller than 4 and 6. I can do root 8 squared plus 4 squared, and I'm trying to see if it equals 6 squared. Root 8 squared gives me 8 plus 16 equals 36. 24 is less than 36. Because my c squared is larger, it is obtuse. Now, this isn't a very hard problem, but you have to show this work in order to prove it's obtuse, okay? This is one of the few problems that you must show all your work to receive full credit, because otherwise you're just taking a wild stab in the dark. ABC. Okay. 20 squared plus 21 squared gives me 841. 28 squared, 784. So this is larger. Because this is larger, that would be acute. Okay. And lastly, hopefully you guys are getting the idea here. Okay. Much the same. And really all I need to see is this first line and then your last line. That's good enough. You can do most of the work right here. 1521. Therefore, it's a right triangle. Okay. All right. Use a calculator to approximate the given value to 4 decimal places. Remember to check the mode to make sure your calculator's in degrees. I put this on here just to show you guys once again. Here is your mode button on your calculator, and you want to make sure your calculator is in degree mode, okay, which I am right now. So sine 45 is 0.7071. Okay, and cosine 47. Now, you see how the fifth number is 9, and this would round this up to 0, which would bump this over. So to 4 decimal places, this is actually 0.6820. Okay. All right. Simplify the following radicals. Don't use a calculator. No, you're allowed to use a calculator. Sorry, that should have been erased off of there. Square root of 108. You can always check first. Okay, so 10.39 doesn't work. Now I'm trying to see a big number that can go into it. Let's see here. We can go with 100. You can keep working your way down. 64. That should be too big. Let's try like 36. There we go. 36 and 3. You can just keep going down the line just to save a little bit of time here. I just kind of went right to the answer. Now, what's the square of 36? 6. Root 3. Very good. Okay, 320. (64 and 5). Again, just play around until you find the one that works. 8 root 5. If anybody wants to remember how to go ahead and find all your perfect squares in your graphing calculator, we'd be more than happy to show you guys. Okay. All right. Find the value of each variable by using property special right triangles. Keep answers in radical form. All right. On test, we're going to say this: special right triangles. Okay. Special right triangles. So we know we're doing 30, 60, 90. We're doing 45, 45, 90. So across from this first one's 36 because I had 60 here. Across from 30 is your x. Across from 60 is your x root 3. Across from 90 is your 2x. This is the nice one. See how x equals 8 right over here? So it's 8 root 3, 16. Hope that you get one like that on your test. It's really, really nice. Okay, so like whatever, maybe if this was like a 5 root 3, 10. Okay, follows the pattern. Here's the easy 45, 45, 91. Across from it, 45 you put x root 2. Okay, so there are two ratios. Pardon me. X equals 7, which means this is 7, which means this is 7 root 2. Pardon me again. Alright, these are a little bit harder ones. Across from 30 you put x. Across from 60 you put x root 3. Across from 90 you put 2x. Alright, the only thing I can work with is x root 3 equaling 8. Divide by both sides by root 3. And we have to rationalize it. Can I divide 8 by 3? Hopefully we're all feeling comfortable enough to say no. So it's 8 root 3 over 3. But now I need the 2x. When you do this, it's like 2 over 1 times 8 root 3 over 3. You only multiply tops and bottoms. 16 root 3 over 3. There you go. Okay. Like I said, more difficult than before. This one a little bit, well, it can be really easy with a shortcut. Can you guys see how here's my 45, here's my 45, here's my 90. So I got my x and my x root 2. X root 2 equals 10. Just do your shortcut. What's 10 divided by 2? 5. Boom. And this one's the same over here. Okay. So this was 12. These would be 6 root 2s, so on and so forth. All right. I do believe we have 5 problems in the back. All right. So we'll see. Well, I actually gotta bust this one out real quick with you guys, and we'll save the last 4. Find the sine, the cosine, tangent of A from the following triangle. So here's your angle A, here's opposite, here's adjacent, here's hypotenuse. So sine of A equals opposite over hypotenuse. How do I know this? Well, here's my SOA. O over H, cosines A over H, tangents O over A. Alright. So, for sine, opposite of hypotenuse, 12 over 12 root 2. What happens to your 12s? They become just 1. Have to multiply top and bottom of root 2. Root 2 over 2. Okay, not too bad. Just rationalizing denominators there again. Adjacent. Yeah, what do you know? Adjacent's the same exact thing. 12 over 12 root 2. Guys, here's a question for you. Should I divide 12 and 12 by 1, or by 12, to get 1 over root 2, and then I can rationalize the denominator? Please shake your head no all at the same time when you do this, because you did all the work up here. If it's the exact same thing, which is possible, right, just write the answer down. Don't reinvent the wheel. Lastly, this is the hardest one, opposite over adjacent, 12 over 12. That was sarcasm. What's 12 over 12? 1. We're all good. Just quick curious, anybody see what special right triangle this is over here? X, X, X root 2. This is actually a 45, 45, 90 triangle. Okay, which this is actually stuff that you will find out in pre-calc, or honors pre-calc in just a few years on the unit circle. So, I will save the last 4 problems to go over either in class, or I'll make up another short video real quick for you guys. Tomorrow we will hit the open-ended, but as always, keep up the good work and good luck.